66 million years ago, a creature the size of a school bus was hunting its next meal. But here's the thing. Scientists got it wrong for over a century. What ancient animals actually ate is nothing like what textbooks told you. Some of the deadliest predators on Earth were secretly plant eaters. Some of the most harmless-looking creatures were vicious killers. And one ancient animal had a diet so bizarre, researchers still argue about it today. The food chain of the ancient world was weird, and we're about to break all of it down.
Before we get into the animals, let's set the stage. The ancient world wasn't one time period. We're talking hundreds of millions of years of Earth's history. From the Cambrian period, where life was mostly ocean slime and weird spiky worms, all the way to the Ice Age, where giant mammals roamed frozen plains. Every single era had its own food chain, its own hunters, its own prey, and its own completely strange eating habits. And the reason this matters is simple. What an animal eats tells you everything about it. It tells you how it moved, where it lived, how smart it was, and how dangerous it was. Diet is basically the biography of a creature. So we're going to move through time and look at some of the most fascinating ancient animals and reveal what they were actually putting in their mouths. Some of these will surprise you. One of them might genuinely disturb you.
Number 1. The fossil record is a menu nobody asked for. Here's something most people don't think about. Every fossil that gets dug up is basically a clue about dinner. Scientists look at teeth shape, jaw structure, stomach contents. Yes, some fossils actually preserve stomach contents, and even claw design to figure out what an animal was eating millions of years ago. Flat, wide teeth usually mean plants. Sharp, pointed teeth usually mean meat. But sometimes, the teeth lie. There are ancient animals with flat teeth that were carnivores, and animals with sharp teeth that mostly ate fish or insects. The body doesn't always follow the rules. One of the most famous examples of this is the Heterodontosaurus, a small dinosaur from the early Jurassic period. It had a mix of flat, grinding teeth and sharp, fang-like teeth in the same mouth. For years, scientists argued about whether it was a meat eater or a plant eater. The answer? Both. It was an omnivore. It ate whatever it could find. Plants, insects, small creatures. Like a prehistoric raccoon with a dinosaur body. And that's the first thing the fossil record is trying to tell us. Ancient animals were far more flexible with food than we assumed.
Number 2. Size did not determine the menu. The second thing scientists have had to completely rethink is the connection between size and diet. For a long time, there was an assumption. Big animal must eat a lot of meat. Small animal probably just nibbles on plants or bugs. That logic falls apart almost immediately when you look at real prehistoric life. Take the largest animals to ever walk the Earth, the long-necked sauropod dinosaurs, creatures like Argentinosaurus and Brachiosaurus. These things were the length of 3 school buses. They weighed more than 10 elephants combined. And they ate plants, exclusively. They had tiny heads on enormous bodies. Their teeth were simple pegs, not designed to chew, just to strip leaves off branches. They swallowed vegetation whole and let their massive digestive systems do the work. Now, flip it around. One of the most dangerous and efficient predators in prehistoric oceans was not a giant. The Mosasaurus gets all the movie attention, but the Dacosaurus, a much smaller marine reptile, had a skull built purely for crunching through bone and shell. It hunted aggressively in a body far smaller than what most people imagine as a top predator. Big didn't mean carnivore. Small didn't mean harmless.
Actually, stop for a second. You know what's wild? There's a plant alive today that hasn't changed in over 350 million years. It was around before the dinosaurs, before most complex land animals even existed. The ginkgo biloba tree. Same tree, same leaves, still growing in cities around the world right now. Ancient animals were eating its ancestors, and we're out here making supplements from it. Okay, back to the food chain. Let's talk about one that had the biggest reputation makeovers in science history. T-Rex, the obvious one. For most of the 20th century, Tyrannosaurus rex was shown as a pure, relentless killing machine. Always hunting, always chasing, pure predator. Then scientists started looking more carefully at the evidence. T-Rex had incredibly powerful jaws, one of the strongest bite forces ever measured in a land animal. But its legs? For its size? They weren't built for speed. The bone structure suggests it may have moved at a walking pace most of the time. And here's where it gets interesting. Many T-Rex fossils show signs of feeding on already dead carcasses, tooth marks deep in bone, the kind of feeding behavior you see in scavengers cleaning up a meal, not fresh predators. The current thinking among most paleontologists is that T-Rex was both. It hunted when it could and scavenged when the opportunity was there, like a hyena the size of a dump truck. It wasn't the noble apex predator of the movies. It was more like the ancient world's opportunistic garbage collector with a massive bite.
Now let's talk about one that surprised everyone. Spinosaurus, the largest carnivorous dinosaur ever discovered, longer than T-Rex, more intimidating in many ways. For years, it was shown as a land predator, a giant that dominated the ground. Then, scientists found new fossils in Morocco, and the bones told a completely different story. Spinosaurus had dense bones, the kind that help with buoyancy control in water. It had short back legs, not ideal for chasing prey on land. Its nostrils were positioned high on its skull, great for an animal that spent time with its face near water. And the teeth? Long, thin, conical. Not designed for tearing through thick dinosaur flesh, designed for catching slippery fish. Spinosaurus, the biggest carnivorous dinosaur to ever exist, was primarily a fish eater. It likely waded or swam in rivers and shallow water, snatching large fish the way a grizzly bear does in a salmon stream today. Nobody predicted that.
Speaking of fish, the largest fish to ever live was Leeds ichthyes, an enormous filter feeder from the Jurassic seas. Scientists estimate some individuals may have reached over 16 meters in length. What did it eat? Plankton, tiny shrimp, microscopic creatures. The biggest fish in history was out there hovering in the ocean, mouth wide open, eating things too small to see with the naked eye. Never assume size equals power in the ancient world. Ever.
The ocean has always been the most extreme environment on the planet, and in prehistoric times, it was a full-on horror show of eating habits. Let's go back to the Cambrian period, around 500 million years ago. The top predator of the time was Anomalocaris, an ancient arthropod that looked like someone mixed a shrimp with a jet engine. It had circular, claw-like mouthparts and compound eyes. For a while, scientists thought those mouthparts were rigid, built for crushing hard-shelled prey. Then, better fossil analysis revealed they were more flexible than expected. The leading theory now is that Anomalocaris may have been a filter feeder for at least part of its diet, scooping up soft-bodied creatures and plankton. An apex predator that might have also eaten like a whale. The ancient oceans kept doing this, producing animals that defied expectations.
Then there's the Dunkleosteus. This is one of the most terrifying fish ever described by paleontologists. Dunkleosteus lived around 360 million years ago. It had no teeth in the traditional sense. Instead, its jawbones were sharpened into blade-like cutting edges, self-sharpening edges that sliced through whatever they closed around. Its bite force is estimated to have been among the highest of any fish ever. And what was it eating? Other armored fish, sharks, cephalopods, whatever it encountered. And here's the detail that really stands out. Fossil stomach remains linked to Dunkleosteus show partially digested prey that was regurgitated, meaning this fish would eat and then spit out the parts it didn't want. Bones, shells, tough tissue, gone. It kept the good stuff. A prehistoric apex predator with the dining manners of someone picking the toppings off a pizza.
Completely unrelated, but have you ever thought about how strange it is that we know what these animals ate? but we have almost no idea what sounds they made? Dinosaurs, ancient sea creatures, giant mammals? We can reconstruct their skeletons. We can figure out their diets with serious confidence. We can even estimate their intelligence. But what did a Dunkelostheus sound like? Total silence in the fossil record. No vocal structure preserved. We have no idea. Some researchers think many large prehistoric creatures were mostly silent. Others think they communicated through vibrations in water or ground. But honestly, nobody knows. A whole world of creatures we will never actually hear. Okay, back to eating.
Plant eaters tend to get ignored. They're not as dramatic as the predators, but the herbivores of the ancient world had some of the most complex and interesting diets in history. Let's start with the Triceratops. Everybody knows what it looks like, the three-horned dinosaur with the neck frill. Most people assume it just wandered around eating whatever plants were nearby. But look closer at its skull. The beak at the front of its jaw was designed for cutting, incredibly precise cutting. And its teeth were arranged in what scientists call dental batteries, rows of teeth that replaced each other as they wore down, always keeping a fresh cutting surface. Triceratops wasn't just eating any plant. It was eating tough, fibrous, hard-to-process vegetation. Some researchers believe it was specifically targeting low-growing plants with thick stems, plants that most other herbivores passed over or couldn't process. It had a specialized diet, a niche. It was the ancient world's picky eater that actually had a strategy.
Now let's talk about the hadrosaurs, the duck-billed dinosaurs. These were some of the most successful plant eaters of the late Cretaceous period, and their diet was surprisingly varied. Some hadrosaur fossils have been found with preserved stomach contents. Inside, a mix of plant material, leaves, seeds, twigs, and rotting wood. Rotting wood. These dinosaurs were eating decomposing timber, not because they had to, but likely because rotting wood is rich in fungi and insects, which add protein and nutrients to an otherwise plant-heavy diet. Hadrosaurs were essentially supplementing their salad with whatever was living inside old logs. Even the herbivores were working angles.
The Ice Age produced some of the most well-known prehistoric mammals and some of the most misunderstood diets. Let's start with the woolly mammoth. Popular image, a peaceful giant wandering through snow, eating frozen grass. Reality, a highly strategic grazer with a diet that changed depending on the season. Isotope analysis, a scientific method that reads the chemical record locked inside bones and teeth, has shown that woolly mammoths shifted their diet throughout the year. In warmer months, they ate grasses and flowering plants. In colder months, they switched to shrubs, bark, and anything they could access beneath the snow. They used their curved tusks to sweep snow aside and reach buried vegetation. Some individuals showed significant tusk wear on one side, suggesting they were right-tusked or left-tusked, with a dominant side they preferred for digging. Mammoths weren't just eating, they were problem-solving for food.
Then there's the saber-toothed cat, specifically Smilodon. Those massive canine teeth are the most iconic feature. And for decades, the assumption was simple. It used those fangs to stab and kill large prey instantly. But the fangs of Smilodon were actually more fragile than they look. They were long and curved, impressive for display and for delivering specific killing bites, but not built for heavy, sustained bone-crushing work. Current research suggests Smilodon targeted the soft, vulnerable areas of large prey, the throat and abdomen, delivering precise killing strikes rather than wrestling with prey for extended periods. It was likely hunting mammoths, giant ground sloths, ancient bison, and horses. And here's the social behavior angle. Fossil evidence suggests some Smilodon individuals survived significant injuries for extended periods, which implies others in the group may have shared food with them. A predator that possibly took care of its injured, sharing meals with saber teeth.
Actually, giant ground sloths. Let's pause on that for 2 seconds because they deserve more attention.
Megatherium, the giant ground sloth, stood about 6 meters tall when it rose on its hind legs. It weighed several tons. It had massive claws. And it was a plant eater. But those claws? Scientists have debated whether Megatherium occasionally scavenged meat, using those enormous claws to access carcasses already killed by other predators. A giant, slow-moving sloth that might have stolen meals from saber-toothed cats? The audacity!
This is the section where the ancient world really stops making sense. Case 1. Pachycephalosaurus. This dinosaur had a dome-shaped skull up to 25 centimeters thick. The iconic image is two of them headbutting like ancient rams. The diet assumption? Pure herbivore. But recent analysis of jaw structure suggests Pachycephalosaurus may have been an omnivore, capable of eating plants, small animals, and insects. A head-butting dinosaur with a skull built like a helmet that also ate bugs.
Case 2. Ancient crocodilians that ate plants. Modern crocodiles are pure carnivores. Ancient relatives? Not always. Semiotosaurus and several other ancient crocodilian relatives had skulls and teeth that pointed toward a primarily plant-based or omnivorous diet. Some had blunt, rounded teeth, completely useless for catching fish or tearing meat, built for processing tough vegetation. Ancient crocodile relatives that were essentially eating salad. The modern crocodile did not get that memo.
Case 3. Repenomamus, the mammal that ate dinosaurs. This one tends to stop people cold. Repenomamus was a mammal that lived during the early Cretaceous period, when dinosaurs still dominated the land. It was roughly the size of a large dog. And inside one Repenomamus fossil, scientists found the preserved remains of a juvenile dinosaur in its stomach. A mammal eating a dinosaur during the age of dinosaurs. The ancient world's food chain didn't always flow in the direction we imagined. Mammals weren't just cowering in the shadows during the dinosaur era. At least one of them was out there grabbing young dinosaurs for a meal.
You know what the strangest part of all this is? The more we dig, literally, the more the food chains of the ancient world look like they were just barely organized chaos. Every time a clean, simple narrative gets built around what an animal ate, a new fossil shows up with stomach contents that flip everything. Science doesn't get offended, it just updates, which honestly makes paleontology one of the most exciting sciences out there, because the ground still has answers we haven't found yet.
Here's where it gets deep. Diet isn't just about survival day to day. It's directly connected to extinction. When environments change, when forests shrink, when temperatures drop or rise, when prey populations collapse, animals with highly specialized diets are the first to disappear. The giant panda is a modern example. Bamboo accounts for nearly all of its diet. Reduce bamboo availability, and the panda struggles to survive. In the ancient world, this played out repeatedly and on a massive scale. The woolly mammoth's food sources became increasingly stressed as the climate warmed at the end of the Ice Age. The large grasslands they relied on shrank, and combined with human hunting pressure, the mammoth's diet-based dependence on specific environments became a death sentence. Smilodon likely collapsed because its main prey, the large megafauna it specialized in hunting, disappeared first. Remove the food, and the predator follows. Animals that were generalists, animals with flexible diets, like the prehistoric raccoon-like omnivores, had much better survival odds. Flexibility in diet was essentially a survival superpower, and the ancient world kept proving it, over and over, across hundreds of millions of years. Here's the thing that makes all of this even more interesting. We are still in the early stages of understanding ancient diets. New techniques, isotope analysis, protein extraction from fossils, microscopic examination of dental plaque on ancient teeth are changing what we know right now. Ancient dental plaque. Scientists can actually extract preserved plaque from the teeth of animals that died millions of years ago analyze the trapped organic material inside it and identify what those animals were eating. A microscopic record of ancient meals locked in mineralized tooth residue, waiting to be read. This has already produced surprising results for ancient hominids, early human relatives, revealing that their diets were far more varied than expected. And the same methods are now being applied to ancient animals across multiple species. Every few years, a major paper drops and rewrites a chapter of what we thought we knew. The ancient world's menu is still being written.
And that's what makes one discovery, found just a few years ago, so significant. A fossil site, multiple species preserved in extraordinary detail. And inside the stomach cavities of several predators at this site, scientists found something they genuinely did not expect to find. Prey animals that, according to everything known about the food chain of that era, those predators should not have been able to catch. The size difference alone made it seem physically impossible, but the evidence was locked right there in the rock. Which means either the predators were hunting in ways nobody had modeled, or something about how we understand ancient ecosystems is fundamentally incomplete. And the team studying that fossil site has not yet released their final conclusions. Now, here's a question worth thinking about. If one fossil site could rewrite an entire chapter of prehistoric history, what do you think is still buried out there that we haven't found yet?